Alright, this video is going to be about the things that you can find from a rational graph, a rational function that you're about to graph. All the things that we can find looking at the equation itself. And then later we'll go ahead and look at all the extra things we get from the graph. So, characteristics that can be found from the original equation. Hopefully you recognize this from Honors Math 3 last year. I believe you guys used this as one of your graphic organizers. So we're just going to use this to remind ourselves of how this stuff works. So one of the things you can find from the original equation before it is factored is the y-intercept. You can also find a horizontal asymptote. And you can also find an oblique asymptote. Alright. And then I did kind of a poor job of laying out these notes because I did not leave space for the next thing. So what I'm going to do is I'm going to go ahead and write it at the top of the page and just kind of draw arrows down. So if you guys recall how to find a horizontal asymptote, you know that you have a horizontal asymptote if the numerator degree is less than the denominator degree. That's one circumstance. Or if the numerator degree equals the denominator's degree. So on this example you can see the degree of the numerator is 1. And the degree of the denominator is 2, it's to the second power. And so with this one, anytime your numerator degree is less than your denominator degree, the asymptote is y equals 0. That's a horizontal asymptote. And we have to write y equals 0. We can't just say that the asymptote is 0 because this is the equation of a horizontal line. So you got to make sure that you write that in there. Next, if the two degrees are equal, then you're going to look at the coefficients. I'm just going to write that. And we're going to write them as a fraction. So for instance, if the top had been x squared, and so we had x squared on the top and 2x squared on the bottom, then the horizontal asymptote there would have been y equals 1/2, because this has a coefficient of 1 and that has a coefficient of 2. So just be careful to remember those two things. So there is that right there. It's for horizontal asymptote. And then for oblique asymptotes, we're going to know that we have an oblique asymptote if the degree of the numerator is bigger than the degree of the denominator by exactly 1. So it could be the top has an x to the third and the bottom has an x squared. It could be the top has an x to the 17th and the bottom has an x to the 16th. So they have to be different by exactly 1. That's how you know you have an oblique asymptote. And then what you're going to do is do polynomial long division. Yay, that's why we reviewed it. And your equation has to be in the form y equals mx plus b. And that's why they have to have a difference of 1, because when you divide them, you want your solution to only have an exponent of 1. And the nice thing about this is typically it means we will not have to do polynomial long division all the way through. We can do it a little bit of the way through until we get the first two terms, and then we're done, which is nice. So this part goes right here to the oblique asymptote. Okay. Next, we're going to look at the things that can be found from the factored form. So here, now they've factored it over here, and these are all the things we're finding. So first, we can find the x-intercept. It is whatever makes the top of the fraction equal 0. Next, we can find the vertical asymptotes. They are the things that make the bottom equal 0. If you have a factor that cancels out on the top and the bottom, that's where the holes come from. And then if you recall back to the unit we learned about already, anytime you have a fraction, whatever numbers are on the bottom of the fraction that would make the bottom of the fraction equal 0, those are values that are excluded in your domain. And so we can actually find the domain from these using the factored form. And there's a couple things I want you guys to fix about these notes. First, with the domain, I think we all know that I would not like this answer. I want you to write in all real numbers before you do that. So go ahead and switch this so it says all real numbers, and then you're skipping -1/2 right there for the vertical asymptote, and you're skipping 1 for the whole, so that's what the domain is saying. And then for the value at a whole, we can actually find the y-coordinate. And so what we do is we look at this this expression right here where we took what was factored out, and if you factor out everything on the top and it all cancels, then you're just going to have a 1 left over on the top. And then on the bottom, I have 2 times x plus 1, and what I'm going to do is I'm going to do 2, and I'm going to multiply it by 1 for the x value, because that is the x value for the whole of the graph. And then I'm going to go ahead and simplify this. So I have 1 over 2 plus 1, which is 1 over 3, and so the whole is actually 1/3. And it is pretty easy to find, and it's going to be beneficial for us later because we are going to use that to help us find specific things. Okay, so those are the things that we can get just looking at the equation. Now there are other things that we're going to get from looking at the graph, and those are things that we're going to do a little bit later. So the range is something that we have to look at the graph to get. The next thing we have to look at the graph for is the maximum or minimum. And then the last thing is increasing and decreasing intervals. And the reason all these we need the graph to find is because often they are not nice numbers. I don't know a way to algebraic. This is decreasing. I'm sorry, those letters are terrible. I don't know of a way to algebraically solve for those, and so we have our calculator help us find those values so that we can write them down. Okay, so we're going to do an example just to make sure that you guys can still do this process. So you have the 2 examples up here you can kind of look at, but we're going to do one more. So our original expression is going to be x to the 3rd plus 2x squared minus 8x, and then we're going to have 4x squared minus 64. All right, so the first thing I'm going to look for up here is the y-intercept, and I can see the y-intercept by looking at the numbers on the end that don't have x's. So on this one, -1 over -1 made a y-intercept of 1. On this one, -8 over -2 made a y-intercept of 4. So on this one, I don't have a number on the end, so I'm going to add 0 on the end. And then I'm going to look at that. 0 divided by -64 is just 0. So that means that I have a y-intercept of 0, 0. Next, I'm going to look to see if I have a horizontal asymptote, and you'll notice the degree of the top of the numerator is bigger than the bottom by exactly 1. So go ahead and cross out horizontal asymptote. This is actually an oblique asymptote, which means we get to do some long division here. So I'm going to go ahead and set up the problem. I have x to the 3rd plus 2x squared minus 8x plus 0. And then in the front, I have 4x squared minus 64. And I know that we talked about missing powers, and you only have to worry about missing powers if they're missing in this part. It's okay if they're missing over here. We'll be able to work with that. All right, so I have to ask myself, 4x squared multiplied by what is x to the 3rd? And the answer is 1/4 x. And it's going to be very common for this to work out, which kind of makes sense because we're about to get something in y equals mx plus b, and so having a slope that's a fraction is a pretty common occurrence. Okay, so 1/4 x multiplied by 4x squared is going to be x to the 3rd. And then 1/4 x multiplied by -64 is actually -16x. So see how since I had a missing power, I just kind of moved that over here. Okay, and now I'm going to subtract these, which means I'm going to change the sign of everything. And then write down what I have left over, so that's just 0. And then this, I've got nothing here, so I'm going to go ahead and just bring it down, 2x squared. And -8x plus 16x is positive 8. Alright, and then I can do it again. So 2x squared multiplied by something is 4x squared, and that something would be 1/2. And at this point, I have enough information to write this as y equals mx plus b, so I'm done. I do not have to do any more in this polynomial long division problem. So I have y equals 1/4 x plus 1/2. So that's kind of nice, we're done there. Okay, now we're going to go ahead and factor this. So on the top, I'm going to go ahead and factor it off to the side. So on the top I have a GCF of x, so I'll write my leftovers. And then I know I'm looking for two things that multiply to -8 and add 2. And so it'd be x plus 4 and x minus 2. And then on the bottom I have a GCF of 4. And then this is difference of squares, so that's going to be x plus 4, x minus 4. Alright, and I can see I have the x plus 4 that cancels out. Okay, so let's find all the things here. So we have x-intercept. So right here I have an x-intercept of 0, 0, which makes sense, right, because that point is on the x-axis and the y-axis, so it should be an answer for each of them. And then over here I have an x-intercept of 2, so 2, 0. I have a vertical asymptote of x equals 4, and I'm being careful to make sure that looks like an equation of a vertical line. I'm not just putting 4 as the vertical asymptote, I'm putting x equals 4. For my domain I can say all real numbers, but I can't have -4 and I can't have +4. And then for the whole, I know that the x-coordinate is going to be 4, and I have to do a little bit of math to find the y-coordinate. So I do not use the factors that canceled out, but I do plug in a 4 everywhere else I see an x. So I'm going to plug in 4 right here, and I'm going to plug in 4 minus 2. I'm going to plug in, and that 4 was already there. And then I'm also going to plug in 4 minus, oh, it was -4. Sorry. So I plug in a -4 here, a -4 here, and then -4 minus 4. I caught myself when I was about to make it equal 0 right there on accident. Okay, so I'm going to go ahead and just cancel out these 4s so I have smaller numbers to work with. So I have the negative version of -6, which is going to give me +6. And then down here I have -4, and -4 makes -8. And so that simplifies to -3/4.